All right, so this is for my pre-calculus algebra students. We're going to find the difference quotients that we skipped in lecture today. I've written out the steps, and I want you to follow along. Got to make it nice and pretty. And I'm going to show you the process. So the example we did in class was a linear equation. We found out that the difference quotient for a linear equation is the slope of a linear equation. So what happens when I change it? So this is a quadratic function. G of x is equal to 5x squared minus 2x. And the process is the same as always. Step one, find f of x plus h. What we're doing is we're finding the first term in the numerator of the difference quotient. And for us, our function is actually called g, so we will be finding g of x plus h. So g of x plus h, again, just remember wherever we have g of x right here, g of x plus h just means everywhere there's an x, you now have x plus h. All right, now x plus h squared is, remember, that means x plus h times x plus h. And, oopsie, look at what I did. I didn't swap out that second x like I was supposed to. All right, so that's minus 2 times x plus h. I'm going to multiply, multiplying the x plus h's together first and then distributing the 5, I believe, is easier. X plus h times x plus h is x squared plus 2xh plus h squared. And then I'm just going to write that last piece again, 2 times x plus h, and now we're going to distribute for both of these. So the 5 gets distributed to this polynomial, and the 2 gets distributed to this binomial. And I now have 5x squared plus 10xh plus 5h squared minus 2x minus 2h. Okay, are any of these like? No, they're not, right? The first term has x squares, the second one has xh's, third one has h squares, fourth one has x's, fifth one has h's. It's not enough. I can't put the x squares and the x's together. I can't put the h squares and the h's together. So that is step one. I have found g of x plus h. All right, step two, find g of x plus h minus g of x. Okay, and all that is just the entire numerator of the difference quotient. G of x plus h we just found, minus g of x is equal to all of that, 5x squared plus 10xh plus 5h squared minus 2x minus 2h minus, and then what is g of x? It's the original function. What is the original function g of x? It's 5x squared minus 2x. Okay, now that's going to get, that minus gets distributed, or we can look at it as 5x squared minus 5x squared. I don't need to distribute it on paper and then subtract everything away. 5x squared minus 5x squared is 0. Negative 2x minus negative 2x is negative 2x plus 2x, which is 0. So those go to 0. And I'm left with 10xh plus 5h squared minus 2h. All right, so that's step 2. Now, step 3 is to find the entire difference quotient, f of x plus h. And again, we're dealing with g, so let's make that g of x plus h minus g of x, all divided by h. Well, I found that already, right? G of x plus h minus g of x is the result from question 2. So what is it? G of x plus h minus g of x all over h is equal to 10xh plus 5h squared minus 2h all divided by h. And then I know I'm done when I can plug in 0 for h and I don't cause division by 0. Can I do that yet? Absolutely not. All right, that h down here is going to be a problem. So I can look at this, I can do this 2 ways. I think the easiest way is to say, look, all 3 terms in the numerator have a factor of h in them. So I'm going to factor that out. When I pull out that h, that leaves me with 10x plus 5h minus 2 all divided by h. And now these divide, leaving 1s. And I find my difference quotient to be 10x plus 5h minus 2. So there's the difference quotient for a quadratic equation. All right. Now I want you to notice, remember as we were working into the problem, we're supposed to be able to plug in 0 for h and get our and get something that doesn't divide by 0. That's exactly what we did here. Why were we able to get rid of this h? Because in step 2, all the terms that remained in the numerator all have a factor of h in them. So that's going to happen anytime you got a square, anytime you got a second degree polynomial and you're finding the difference quotient for it. All right.